Thank you everyone for coming to our webinar. The topic of the day is optimizing building ventilation to mitigate virus spread. So before we begin, I just want to touch on a few items. Many of them Kareem has already touched on. Number one, our presentation today will be 1 hour long. Two, as Kareem mentioned, you all have the power to unmute yourselves to ask questions. Please do so respectfully. If things get chaotic, we may have to impose a mute on everyone and refer to the chat only to ask questions. That being said, we will be pausing to ask questions and answer questions, so please ask them when they come up. Finally, AIA credits are available for this presentation. If you informed us during the sign-up process that you needed them, they will be processed later this week. If you've not let us know already, please email rsvp@abbae.com and we will get those handled. But enough with the rules. I would like to introduce the two men of the hour, Mr. Kareem Allana, who you have already met, and Mr. John Williams. Mr. Kareem Allana is the CEO and founding principal of Allana, Buick & Bers. Allana, Buick & Bers is a leading architectural engineering and forensic consulting firm specializing in the building envelope and sustainable construction, as well as mechanical engineering. He has 35 years of industry experience and is a master presenter. He has spoken at dozens of trade shows, industry seminars, and ABB-hosted presentations, like this one. Mr. John Williams is the division manager and principal of Allana Buick & Bers' Northern Carolina division. He is responsible for operations and oversight of the North Carolina division's projects. He has over 24 years of experience in construction, facility engineering management, and building operations. For the past 12 years, he has focused on mechanical engineering and has overseen the execution of over 2,000 successful projects. And now, without further ado, I present Mr. Kareem Allana to begin the webinar. Thank you.
Hi, everybody. It's a real pleasure to be part of this. I want to welcome the listeners from Hawaii with a big aloha. And it's a real pleasure to have all of you on today. We're going to be talking a little bit about building commissioning, but before we get started, I wanted to give you guys a little bit of a background on myself and John, and talk about our expertise as a company. Rachel, are you controlling the screen? I'm sorry, I don't have any control over the screen. Or John?
I'm not touching it right now, Kareem. I left it up to you. It was jumping on me.
Okay. Okay, got it. All right, so ABB's expertise is mechanical and HVAC systems, plumbing systems, solar, LED, energy conservation, building envelope, roofing, waterproofing, anything to do with the exterior facades of the building, and window and glazing systems, and a lot of different things. So we have structural engineers, mechanical engineers, and a lot of different people that specialize in various aspects of construction. We have a lot of varied clients. Our clients include AOAOs, homeowners associations, and industrial clients, people like American Airlines, Apple Computers, you know, a lot of varied clients. So essentially, our service is more specializing in the type of work we do rather than the type of clients you are. And our specialization is really to make buildings perform better. And there are many aspects of making buildings perform better, and those include making buildings last longer. Those include making buildings defect-free, and longevity, sustainability, reducing the maintenance cost of the building, operating cost of the building, and how to make buildings operate better. So today's presentation is really about how to make buildings better in terms of our HVAC systems in light of the COVID issues. And so we're going to talk about how we can optimize our air conditioning systems to reduce the spread of the disease. And for that, I'm going to pass the baton to John Williams. John is a mechanical engineer that is out of our North Carolina office, and he serves national clients throughout the country, including clients in Hawaii, although we have as you all know, a big office in Hawaii and in Oahu and in Maui that service that part of the country. We have offices throughout the country, and part of that is our North Carolina office that is primarily a mechanical HVAC systems division. And without further ado, John, take it away and do the presentation.
Thank you, Kareem. As Kareem mentioned, I'm John Williams. I run the North Carolina office, and our group is focused primarily on mechanical engineering. And what I'll be stepping through today is our presentation on the HVAC ventilation optimization to prevent disease and control disease spread. The COVID is obviously on everybody's mind now, and one of the things that the CDC has said is that it's not an airborne disease. And when they say that, we're talking about it's not just floating around, it's not just out there in the air, it's actually being carried by people. And it's transmitted when we cough and sneeze. And when we cough and sneeze, those droplets then can become aerosolized. And those aerosolized droplets then linger in the air, where they can linger for, they're saying, 4+ hours. These droplets then can be transmitted through our HVAC systems. And you can see there in our little graphic on this page, when someone sneezes, that aerosolized droplet then becomes airborne and can enter into our HVAC system. Although the gentleman on the right-hand side of the screen sneezes and he's contained in his own office, those droplets then are circulated through our HVAC system over to our other offices. Now, a lot of people question why, what about the filters in the system? And we'll talk a little bit more about the filters later in this presentation. But for now, we'll just say that the filters are not always effective in capturing those droplets. The CDC actually did a case study on this, where back in the January, February time frame in China, there was actually an HVAC case where a wall unit in a restaurant was attributed to the spread of the coronavirus. In this case study, this little graphic that is shown on the screen, the droplets from person A1, who was the initially infected person, were aerosolized, entered into the HVAC unit on the wall on the right side of the screen, and were eventually spread to the other persons throughout the room, across the other tables, to the other people in the rooms. The dates that you see on the other people in the room are when the other people were eventually diagnosed with the coronavirus. So there's an example of how it was picked up, transmitted through an HVAC system, and spread throughout the room. And although today we hope that we'll eventually be able to neutralize the COVID, we'll either through elimination or vaccination, we'll eventually get past this. There's obviously other known diseases out there, and some potentially that we don't even know about. And these are all reasons why we need to address our HVAC systems and optimize ventilation in our building. Does anybody have any questions on this portion of the, I'm looking for hands going up, but I don't see anything. We'll move on to the next section, which is the CDC recommendations for increased ventilation and what the CDC is recommending. As of today, at least every state in the country is at least partially open, and many of the states are now moving into phase 2 of reopening, which means that our HVAC systems are even more important than ever to maintain a healthy environment as people are coming back into our buildings and trying to prevent this second wave or infection spikes as we reopen. The CDC recommendations to increase the ventilation are, first, as simple as it sounds, you want to make sure your systems are operational. Making sure that units are functioning, that they're running, that we're moving air in the building. More importantly, we're going to want to increase the outside air on these units. And with lower occupancy in our buildings, now that we are scaled back, this basically results in a lot higher outside air per person in our building. Demand controlled ventilation is something that we find in a lot of our buildings, newer buildings or buildings that have been upgraded, where we typically use CO2 monitoring to reduce the amount of outside air during periods of low occupancy. So when we have low occupancy in the building, we're closing off that outside air to save energy. However, because of the coronavirus, we want to actually override that right now, and we want to try to ventilate more. We want to bring in more outside air. This will likely result in some higher energy costs, but the purpose of this is to, again, increase the ventilation in the short term in lieu of higher energy costs. Also, you want to open outside air dampers as much as possible. You want to reduce the amount of recirculated air in the building. You won't recirculate as much, bring more in from the outside. But obviously, this is going to be very dependent on the climate conditions and where you're located. The CDC also says to make sure we're checking our filters and installing the highest MERV rating filters possible. Now, this is going to really depend on what our filter racks are set up for, what they can accept, and more importantly, what our fan horsepower is able to do. If we install too high of a MERV rating in our MERV rated filters in our systems, it's actually going to be counterproductive, and it's going to reduce our airflow in the system. And it's going to reduce the ventilation in the building. So we want to basically find that balance between the higher efficiency filter and the amount of airflow we can move in our building. We also want to seal up the filter edges. Often the filters in these filter racks have degraded over time, and the filters do not fit tightly and snugly in there. And portions of the air are going to bypass the filter. Along with this point, you really want to also make sure the right size filters are installed. And simple as that sounds, many times I've opened up HVAC units and found makeshift filters or filters that are the wrong size installed, which allow air to bypass the filters.
Any questions thus far? I just want to take a moment. I know that part of this is very technical, and and John is a mechanical engineer, and we're trying to speak to facilities people that understand the lingo. We don't have a good sense of the audience as to who everybody is and your technical level of understanding of some of these items. So we really do encourage you to ask questions, and there are some questions that are being asked, and I'm going to read out, John, so you can answer them. One of the questions that was being asked is that increasing outside air is going to increase humidity and moisture problems and mold, and how do you address that?
So how do we address that? And this is going to go back to, again, a climate by climate basis. I don't think that there's going to be a one-size-fits-all recommendation for all the different locations that are possible on this call. I know we have quite a few people from Hawaii. We have quite a bit of humidity in Hawaii, which is going to be a lot different than, say, Southern California. So when we do get into those areas of higher moisture contents, we have to make sure that we're not outrunning our dehumidification capabilities in our machines and our air conditioning units. We do want to increase the ventilation, but again, I think it's going to be on a case-by-case basis that we have to look at the units' latent load capabilities are to be able to dehumidify the outside air we're bringing in. But that's a very great point. It says Rick. I'm not sure who Rick is, but thank you for bringing that up, Rick. It is a very big concern as we get into the moisture-prone areas in the country.
Hold on. There's another question, John, that came up, which is there a suggested amount of air exchange increase? I believe that question is going to get answered in a little bit, but John, please feel free to jump in.
So once again, we'll talk a little bit about where we're going with this a little bit more, but I don't know that there's, again, a one-size-fits-all. We are going to talk a little bit about what ASHRAE recommendations are for the amount of outside air, what the ASHRAE standards are for outside air per person. As far as the increase amount, it's really, once again, going to be dependent on what your system is capable of doing. If we could potentially go to 100% outside air, that would be great. However, a lot of these units are not capable of handling 100% outside air. So really, again, it's going to go back to what our latent load capabilities are, how much we're able to dehumidify. We don't want to get into those moisture issues. And again, it's going to be a case-by-case basis on the buildings and what our existing unit capacity is and abilities to do that.
The other question that came up is that some of the systems only filter outside air. They don't filter air that is being circulated within the building. And obviously, and this particular question came up from a building that's built in the 1954 era. And, part of this is to understand what we're recommending to optimize the ventilation system for COVID. And sometimes it's not going to be possible to make a minor, simple adjustment in your system that'll take care of things just because it's so open. And so I'll let John talk about it, but essentially it is not a one-size-fits-all. I think it's more about trying to bring to everyone's attention the things that we recommend be done. And sometimes it will require modification to the system where you have to bring in an engineering firm to understand the situation and make the changes. Sometimes you're going to have to bring in a contractor to make the changes in the system to make it more compliant. And the severity of the compliance and how much money is spent to do this, a lot of this is going to depend on what your facility does. If you're a healthcare facility or a nursing home, these requirements are fundamentally very important. But if you're a condominium or an office building, those requirements may be different. So really appreciate your questions, and I just want to go back to John.
So yeah, back to the question about the filters. We have a question here about the filters filtering outside air and not recirculated air. That's kind of a unusual configuration, not to be filtering any recirculated air, especially since this person says that they have steam and chilled water systems. So I'm very curious what's protecting your steam and chilled water coils from recirculated air. But that being said, that again is a case-by-case basis where I think we'd have to look at what are the options to install maybe additional filter racks, additional filtering capabilities on those units to potentially help clean up the air that goes through there. We'll talk, we're not there yet, but we do have a little bit more information on filters in here, and filters are not going to solve our coronavirus issues. They are not, the coronavirus is a much smaller particle than even the finest HEPA filters. So filtering will help. We do have the chance of catching it with the filter media, but I don't want anybody to think that the filtering is the solution here. Okay, let me see where we're going. One of the things that I did want, the next thing I had in here was we want to make sure we're changing the filters. So in addition to making sure that the filters fit and there's no bypass of the air, we want to make sure we're keeping up with our filter changes. Typically on a return air unit, that is about every 3 months or once a quarter. And typically on outside air units, it's monthly if it's 100% outside air unit. But those, again, that's going to vary depending on your geographic location and the system use and what the system serves. So filters must be changed. And again, there's no one size fits all. Lastly, the last point on this, on the CDC recommendations is run the systems. And most systems nowadays, we have programmable thermostats, smart thermostats, and we go to these unoccupied settings or setbacks. But what now with the increased sensitivity to ventilation, we want to run these things. We want to run them as much as we can, as Kareem mentioned before, for air changes, and to turn over the air in the building and to keep the air movement going in the building. Right now is not the time to be concerned about your energy conservation as much as it is about ventilating your building.
A question came up about cleaning the coils.
Yes. Let me see. What is the recommendation for servicing of air handlers? Coil cleaning, basic washing, not chemical, and filter changes, Hawaii. Again, filter changes typically, you might have typed this before I went through that, but typically filter changes for the most part, as a general rule of thumb, on a return air unit is once a quarter, on 100% outside units is once a month. And again, that can vary depending on where you're located. I've seen filters in properties close to airports that needed changed monthly, even on return air units. The other thing we'll talk about too is increasing your filter efficiencies. And as we go to higher efficiency filters, they're going to load up faster. They're going to collect more in the filter, and they're going to require more frequent filter changes. So as you increase your filter efficiencies, you might find that your change out frequency increases also.
You're talking about the MERV 13, John, with the higher efficiency filters?
That is correct, Kareem. And there's, we'll be touching on that in a moment also. Another person asked if we have a fitness center that has the capability to open sliding doors for fresh air, would you open them up a little while running the HVAC system? You know, I'm going to sound like a broken record a little bit. It kind of depends on where you're located, Gerald, but yes. And I actually have a slide in here somewhere where we actually say open the windows. So we'll come to that in a minute. But yes, ventilation by opening the windows, if you can do it in the climate you're in, is a fantastic thing right now. You know, that's what we're pushing for. If we could all live outside right now in social distance, I think we would see the coronavirus go significantly down. It's when we, again, when we get in our buildings and we start recirculating the air, and these droplets is really a major problem with the coronavirus. So all those CDC recommendations come came directly from the ASHRAE ventilation recommendations. And for those of you that may not be familiar with ASHRAE, ASHRAE is this American Society of Heating and Refrigeration and Air Conditioning Engineers, which is a professional organization that basically develops standards and technical services for the HVAC industry. So everything we just saw from the CDC, they adopted from ASHRAE. And in addition to all those, ASHRAE had a couple other things that were not picked up by the CDC that ASHRAE recommends. One of those is portable HEPA air filters, cleaning with portable HEPA air filters. As I mentioned before, even the best HEPA filters only go down to about 0.3 microns, and our coronavirus is about 0.1 microns. So we can't be guaranteed that the HEPA filters will capture the coronavirus, but we can hope that, like a bug on the front of a car, the coronavirus is going to run into the HEPA filter and capture it. We capture. Another thing is ASHRAE recommends is ultraviolet germicidal irradiation, or basically, as most people just call it, UV. But we'll talk a little bit about that in the next few slides, because there's a couple things we have to make sure we address when we talk about UV. So first of all, ultraviolet germicidal irradiation is basically, that long word is basically using a short wavelength ultraviolet light, the UVC, which is about 20 nanometers to 280 nanometers, 280 nanometers, to basically disrupt or disable the coronavirus. And if properly applied, it has been shown to be very effective in removing the bacteria and viruses from the air. But the key components here are really intensity and duration. And you have to actually have those two things for the UV to be able to effectively disable the coronavirus. So whenever we talk about UV in air handlers, it's not just a simple application. Typically when we find UVC lights installed in an air handler, they're installed for the purpose of treating the bacteria on the coil. So that cooling coil, where that cooling coil is condensating and sweating, we get a lot of bacteria and mold growing back there. So typically the UVC light that's in there is basically treating that area and trying to cut down the amount of mold and bacteria in that area. It's not really designed to actually treat the air flowing through the unit. It could potentially have an effect on the airborne microorganisms, but that's really going to vary again with the light intensity and the length of exposure. The air velocity typically is going to be too high for those microorganisms to be killed simply by passing through that light a very brief period of time. So the way I like to explain it is I don't get a sunburn when I walk from my house to my car. I'm not exposed. The intensity and the length of exposure is not long enough for me to be sunburned. Just like the air passing through a UVC light, there's not enough intensity or exposure there to necessarily kill what's carried airborne in the airstream. So how do we use UV to kill off the coronavirus? A better application is through upper room UVC. This is typically going to be installed in the upper areas of a room. Because UVC is hazardous to people, it has to be installed above 7 feet. And then we have to be able to circulate air from the room up through that area, whether it's ceiling fans or we have the returns in that area. We have some sort of air circulation in that room to promote the microorganism exposure into that UVC area, that high intensity area up there. I'm gonna stop there. What questions do we have, Kareem? I'm trying to keep up with the presentation and the
Yeah, no, you're doing great.
What do we
Thank you, John. One of the questions was, you know, people are like, somebody from Las Vegas moved to Hawaii and they're asking, I'm used to running things 24/7 in Vegas, but in Hawaii we tend to shut things down and periodically run them. And what are the rewards for running the HVAC system all of the time?
So what are the downsides? Is that what I heard?
What's the downside, right? And I think you previously answered that it's a situational thing that's going to vary from location to location and use to use, you know, so it is going to be a variable and not a cookie cutter answer, I think.
Sure, and I think one of the major downsides obviously is energy usage. You know, that's one of the big things, and you know, we talk about disabling demand control ventilation, or you know, running units all the time, you know, not going to our setbacks or our unoccupied modes. The penalty there is our energy usage. Obviously, we still have some additional runtime on the units, but right now, I think is the time to put those concerns aside and to try to really work to increase our ventilation to protect our population. We'll get back to energy savings. We'll get back to demand control ventilation and occupancy setbacks. And just like, you know, our society will get back to normal. But right now, it's about containing and protecting. And ventilation is key in our buildings. We don't want to recirculate the air. We want to try to ventilate them as best as possible.
So John, in regards to this particular slide, I think a question that came up is that would this UV system be great as an underfloor system?
And I have to see how that was set up. I guess if it was an underfloor where we had the ability to circulate the air through there, maybe that I haven't seen that applied that way. But the key is to get the airborne microorganisms in front of that high intensity light. And because you know, unless we had some way to move the air, circulate the air through an underfloor system where we had a UV system, perhaps. Again, we got to think about cost to do that, and the practicality of doing that. If we have an underfloor system already, potentially. But I think usually it's typically what I'm seeing is it's applied in a high ceiling room. Think of a lobby or some sort of a waiting room or something like that. And we have a high ceiling where we can mount the UVC at an angle where it's basically projecting up above 7 feet, and we're not endangering anybody in that area. Again, it is harmful to people, but yet at the same time, we can circulate air through that area. So again, I think wherever we applied it, we would just want to make sure we have the air circulation through there. And we go back to intensity and length of exposure of the air to in front of the UVC.
John, this is my own question and not other people's questions, but there are a lot of high-end, for example, condominium type units where there's a plenum in the ceiling, which is a fixed ceiling, a hard lid ceiling, and there's, you know, the return air is essentially floating freely in that plenum. Would that be a great location to put this type of lighting system where you already have a plenum that's in the
Potentially, Kareem, yes. Again, we need to look at what the velocity is. So if the air has a high velocity through there and we have a limited amount of exposure time, it may not work. If we have a low air velocity and a plenum ceiling, which oftentimes we do, it's a big volume. It's typically, I'm thinking of say a hotel ballroom. and you have a massive ceiling plenum in there, it's really got a low velocity, high volume but low velocity, and potentially putting UVC lights above the ceiling there. Again, we have if it's a big open area, we could potentially get the intensity and the exposure we're looking for, the duration.
I guess what you're saying is that you make sure that it's carefully engineered and thought through and put in the right place so that it has the impact that you're looking for, not just stick a light up at the ceiling and expect it to work.
Yeah, exactly, Kareem, and I couldn't have said it better. I think that right now with the coronavirus, it being a obviously major concern to our entire country, and the entire world for that matter, right now I do feel like there's a lot of quick fix ideas out there, and quick fix plans and solutions, and to really just go plug in a UV light, I don't want anybody to think it's a quick fix. It's something that has to be looked at, and again, the keys are length of exposure and intensity. We have to be able to, again, I'll go back to the sunburn example, we have to have that exposure time to really have an effect on the coronavirus or any microorganism for that matter.
Are there particular systems, John, that you recommend that people are asking?
I don't have one in particular. There are multitudes of them out there, different manufacturers. We obviously work with a lot of different equipment manufacturers. We've had a lot of experience. We could definitely recommend something if we knew what the application was, whether it was in trying to do, like you said, it above a plenum or just a high ceiling upper room UVC. I'd love to look at that a little bit deeper. And if somebody, whoever submitted the question, if I'll try to respond to them afterwards and maybe try to find out what their application is and see if we can recommend something. Keep things moving. Basically, some of the ventilation codes and filter recommendations, we touched on these a little bit already. Basically, our HVAC systems, a lot of times, I was thinking of speaking to my wife. If I talk to her about our HVAC system, it's strictly a heating and cooling system. So a lot of times people think of the H and the AC, the heating and the air conditioning piece of it, and they forget about the V. It's actually a critical ventilation function that it serves. And in public buildings especially, these systems are designed to bring in clean, fresh air and to remove contaminated air from our buildings. So we had touched previously on some ASHRAE items. I'm not trying to kill people with numbers, but ASHRAE 62.1 says that we need to have an outside air rate of 5 CFM per person and 0.06 CFM per square foot. And when we're using demand control ventilation, which is another ASHRAE requirement for whenever we're doing new projects now, which again is typically CO2 monitoring used to do that, we actually want to turn that off. We actually want to disable the demand control ventilation now with the current conditions. So when we go to the filters, we typically think of higher MERV rated filters, thinking they're better. So, we go from a MERV 8 to a MERV 13. And to an extent, that is true. With the higher MERV ratings, the better the filters are. But one of the things we want to talk about today was the concern with increasing the filter ratings and the potential reduction of airflow as a result of not having enough fan horsepower to overcome the filter pressure drop. So as we go higher and higher in MERV ratings, that filter media becomes thicker and thicker, and it becomes harder and harder to move the air across there. And unless we have enough fan horsepower, we're going to end up decreasing our airflow, which is negatively impacting our efforts to dilute the air and ventilate the building. So typically MERV 13 filters are going to be the best trade-off between filter efficiency and air ventilation in our buildings. But when we go to change these filters, we have to remember a few things. First of all, they could be contaminated. We're talking about trying to potentially capture some of this virus in the filters. We need to be very careful because the filters, when we send somebody up there, they need to have PPE. They need to have bags for the old filters. They can't just be slinging them around. And they should clean and disinfect the unit as part of that filter change out. And because we could have bacteria, virus in other areas of the unit itself. I mentioned this previously, so I kind of jumped ahead a little bit, but the best HEPA filters are only designed to capture 0.3 micron particles, and our COVID is approximately 0.1 micron. So we don't have any guarantee that we're going to capture the COVID in a HEPA filter. There's no guarantee with that. But as I said, there is the possibility of capture just through interaction with the media. It may just run into the media and we may capture it. And therefore, we do think increasing filter efficiency is a recommendation, and we do not recommend anything less than a MERV 8. And again, anywhere between a MERV 8 and a MERV 13 is typically, for the most part, going to be where we're going to say 95% of all those systems out there are going to land in our recommendations for filter efficiencies. Questions? What questions do we have, Kareem?
The question was, how does air ionization work, and would it be more effective than the UVC?
Great question. So we've been looking into some air ionization. There's still a lot of schools of thought out there. Air ionization, there's different ways to do that. We've actually been looking into some cold plasma generation and different things. The key is to have no ozone generation. Ozone is harmful, and a lot of these ionization means or methods will produce byproduct. There's what the word I'm looking for. A byproduct of ozone, and we cannot be putting ozone into our building. So the key is we want to make sure whatever we're doing is we don't have any ozone. How does it work? Basically, it's breaking down the particles. I am no chemist. I'm a mechanical engineer, but I will just say they're breaking down the particles and basically creating less surface area for microorganisms to attach to. And with that basically limits the ability to transmit things through the air. That's a mechanical engineer's explanation of how that works. But again, I will say the key here is no ozone, whether it's cold plasma or ion generation or whatever, no ozone in the building. Anything else, Kareem?
That's it.
Let's keep moving. We're running a little tight on time. We wanted to touch base on a few things that have to do with some high-risk facilities, whether it's hospitals, nursing homes, assisted living care facilities. And when we talk about these, we're really concerned about pressurization zones. Now, we have pressurization zones in other commercial buildings, whether it's restrooms or kitchens, but these are especially critical when we get into our assisted care facilities. And the reason why is because we're trying to contain and prevent the movement of viruses and microorganisms throughout the building. So what we do is we create positive and negative zones to control the airflow and therefore contain our contaminants. So a positive zone is going to prevent contaminants from entering, and a negative zone is going to exhaust contaminants out and prevent them from spreading. Simple graphs, some simple little diagrams here. This is a room with a neutral pressurization. For illustration purposes, I'm sure some people will pick this up. The air volume shown in the air handler only represents the room on the right, so in our diagram. But in this example, we have 200 CFM of air supplied to the room and 200 CFM of air is returned. So therefore, our room pressurization is neutral. There's no air movement from the room on the left to the room on the right. However, if we introduce 25 CFM of outside air, and once again, this is the airflow in the air handlers just for the room on the right, we now supply 225 CFM of air to the room, but we're only returning 200. So now we have a positive pressure of 25 CFM. And this is going to result in airborne particles being pushed from our room on the right to the room on the left. So if we want to contain that, how do we do that? We exhaust 50 CFM from the room. By putting an exhaust fan of 50 CFM in the room, we now supply 225, we return 200, but we're going to exhaust 50. Now, any disease or hazardous materials, anything that may be in that room that we don't want to spread to the room on the left, we're going to contain in that room as we're going to pull a negative into that room. It's very important that we understand where our pressurization zones are. I go to a lot of buildings where I'll just say the exhaust fans are not running because maybe we don't view them as critical, but they are critical because they may be controlling the pressure in the building. Same thing with our outside air dampers. Maybe they're viewed as not being critical, but they probably are critical not only for fresh air, but also to control our pressurization zones in the building. Any questions we have on that? I don't see any questions on that.
The pressurization, I think, is very critical aspect of healthcare facilities, nursing homes, you know, where, as we all know, that the largest spread in any kind of facility has been nursing homes. And, you know, part of this type of concept that the previous slide was mentioning is really important in managing the virus spread within an occupied space, especially with one HVAC system that is common to that occupied space. And so often a modification would need to be done to these systems, either adjusting and controlling the flow of air or adding additional exhaust or additional capacity or duct work to make this work. So it's not simple, but we do believe that it is necessary to lower and prevent the spread in those facilities. Thank you, John. That was really good.
Thank you, Kareem. So now we want to touch on what you can be doing, what you can be focusing on to ensure your current HVAC systems are performing optimally. I've been literally in hundreds of buildings over the past however many years I've been doing this. And the one thing I can say they all have in common is that they rarely are operating as they were originally designed. Over time, these system components become worn. The systems drift from the original design, which is why it's important that we're inspecting them and we're making adjustments for the outside air ventilation and making sure that everything is operating as it was intended to. So regular inspections, test and balance will always help ensure your system is running optimally. One of the most basic items to inspect is that your outside air dampers are open. I think we've kind of beat that horse to death here, but making sure that our outside air ventilation we're getting that outside air, we're bringing it in. Typical units, again, it really varies by location and by application, but typical 20% on the units, 20% of your volume of air is coming from the outside. So, if you go up there and you find a unit that the outside air, the unit's running and the outside air damper is closed, that you should be asking the questions of why. Why is this closed? Why don't we have outside air? Many units, whether they're chilled water or packaged DX type units, they're equipped with outside air economizers. So the economizer opens up when the outside air conditions are favorable and provide 100% outside air to the building. Somebody that asked a question before about a gym and opening up a gym, same idea. We're basically opening up that unit to bring in 100% outside air when the outside air conditions are favorable. That's a great way to optimize the amount of outside air we're bringing in. So we want to make sure those outside air economizers are functional. One of the other things we find a lot when we're inspecting systems and inspecting units is balancing dampers. Often they get adjusted because somebody's hot, somebody's cold in an area. The damper is adjusted to try to get more airflow, less airflow, and the whole system is thrown out of calibration. But rarely are these ever set back to the original set points. Same thing with fire and smoke dampers. We're penetrating these firewalls in the buildings. We have these fire and smoke dampers. And it's not uncommon for us to find that these have dropped. We're pinching off the ductwork or completely closing it off, and we're losing airflow through the building. So it's important to check our fire smoke dampers to make sure that they're also open. Another thing is, typically, in most households and in most businesses now, we find that the thermostats are set to auto. So the auto setting on there. So it's only running when we have a call for heating or cooling. But to increase the air turnover, the air changes in the building, we want to change those, at least for the short term, to on. We want to run that fan. We want continuous air turnover, ventilation, and moving of air in the building. Now, a concern there is if we have the outside air dampers while we're doing this, if they're open and we're bringing in unconditioned outside air and mixing it in our building. So again, this is going to depend on where our location is. If we're in a high humidity area, we may want to make sure that even if we're running that fan, we're only opening the outside air damper whenever we're heating or cooling. So we're not bringing in high latent loads, high humidity into our building. But again, we're at that point, we're circulating more air through the building. Another simple item to inspect are exhaust fans. These are important, as we talked about, to remove contaminated air, to control pressurization zones. And when we're at it, we want to check our exhaust grills, return air grills. These often get kicked up and restrict airflow in our buildings. They're a major point in commercial buildings for dirt and debris to collect. And here, the person that asked the question about opening up their gym, here you go. Open your windows when your conditions allow. This is a great way, whether it's an outside air economizer on your unit or you're just opening up windows. Again, it's a great way to ventilate your building. I recently made it finally to the barber shop, and when I went in, the first thing the barber did was he opened the front door and the back door and propped them open so he could get airflow through his building, which I thought was fantastic. But unfortunately, here in North Carolina, it's getting warm and humid again, and outside air conditions don't always allow us to do this. But take advantage of this whenever you can. When we talked about the pressurization zones, we talked about how it's important to know where those zones are and verify that those zones are operating as designed. There's simple things like smoke sticks. You can buy them online. Take a little smoke stick outside the room, see which way your air is moving. If you don't have that, take a tissue and check your zone. Is the air being pulled into your room or is it pushing out of your room? Check your pressurization zones. That's a really good indication if your systems are working right or not. Any questions on inspecting HVAC systems? We only have a couple slides left, trying to get everybody, stay on time here. And Creamy, I don't see anything.
There's a couple of questions. I'll let you finish up your
Okay.
presentation, and then maybe we can hit those at the end, because I don't want to. People that you're welcome to stay, and we'll answer more questions at the end as well. I just want to make sure that we respect everybody's time and get through the end of it first.
So the last few slides, just a recap of some of the things we've covered today. Aerosolized droplets can be transmitted by our HVAC systems. And we're not just talking about the COVID virus. We're talking about all the different viruses we know now and ones we don't know that may be coming in the future. So we have to be aware of this and work on increasing our ventilation through our outside air dampers, at least temporarily disabling our demand control ventilation. We want to improve our ventilations, even though ventilation may not guarantee, filtration. We want to improve our filtration. It may not guarantee we're capturing the COVID, and it may reduce our airflow, but we still want to improve that. And we recommend a minimum of a MERV 8 and no more than a MERV 13, again, typically. So, and lastly, understand and verify your pressurization zones. Know where you should be negative and where you should be positive. And go around and check your HVAC systems and check your dampers, check your filters, check if your fans are running, and look for those exhaust fans and grills, and open your windows when you can. So that's what we have for today, Kareem. Thank you everyone for attending. Kareem, let's
one of the questions that's still pending is really about sanitizing the fan coil unit, and also changing out filters, how to manage and how to follow the OSHA requirements for safety in regard to changing out filters.
So I don't know that there's any specific requirements or a program for changing out the filters. I would just say that whether it's the dentist or any commercial retail facility, everybody is taking precautions now. And we're talking about filters potentially capturing the coronavirus. So I think it's important that we highlight the fact that when we're taking out the filters, they could be potentially contaminated. And it's important that we treat them as such. So gloves, face masks, probably face shields, bags to bag the material, and then a thorough cleaning of that. As far as cleaning the coils, there's a lot of different coil cleaning companies out there. There's different coil cleaning products out there. Off the top of my head, I'm not going to recommend one in particular, other than to say that it's important that we are cleaning them and not just the surface. Some of these coils can be 4 rows deep, and it's important that we're cleaning all the way through the coils. So there's professional coil cleaning companies out there if you don't have the ability to do that in-house. Carbon filters, John asked about carbon filters. They are basically for odor removal. Yes, you are correct. They're primarily for odor removal, not for any kind of protection against the coronavirus.
One of the other questions that people have asked is about, are we going to make this presentation available if you guys want to view it offline or pass it on to someone or share it with your coworkers? If you would register, we will make it available in 48 hours. And we have a video recording of today's session that will be available, and you would have to get it off our website. We will send a link to everybody that has registered and everybody that provided us with an email address, and has attended today's seminar, we will be sending them a link. And by clicking on the link and entering your name, you'll have the opportunity to actually watch it and repeat the seminar live. Any other questions from anybody? Awesome. Well, thank you so much, everybody, for coming and attending, and thank you especially for asking wonderful questions that really gave us an opportunity to understand your needs better and be able to talk about it. Thank you so much.
Yes. Thank you.
Bye-bye.
Thank you.